Assalamualaikum warahmatullahi wabarakatuh and good day. Thank you YouTube subscribers and viewers of this channel. This video is dedicated to all environmental auditors, including fresh auditors, students and resource persons who may need to have some idea of what to look for when they perform a practical on-site audit. Yes, an environmental audit of a technical nature. So if your audit scope involves site verification of a pollution control equipment called the scrubber, then this video may just be for you. So before we continue, I need to remind all my Muslim brothers and sisters, if you are already in a mosque for the Friday prayer khutbah or religious lessons and preachers, please do not watch my video, turn it off and pay attention to that. I wish you all Jannatun Naim. Okay then, let's begin now. Well, philosophically, we do not need to control pollution if we didn't produce them, right? Inevitably we did. So in principle, we are committed to ensure by all possible means that the load of pollution we are emitting, in this matter the air pollutants, shall not cause detrimental impact to the environment and its inhabitant. Thus, we are accounted for or be held responsible if our air pollutants poses threats or has caused those negative impact to the environment, the heritage of mankind. So we have addressed and mitigated air pollution issues usually at the end of the pipe. One of them is this scrubber. Here's a chemical scrubber. Oh, this picture was taken at a factory in a town called Nykøbing, Denmark, back in 1998. Well then, a scrubber is used to filter by means of physical contact between pollutant particles and the scrubbing agent. Yes, it's a form of trap or filter in layman terms. How does it work? Physical. The air pollutants, which are usually traveling along with the air, which is moist, so referred to as wet gas streams in this slide, is pushed to flow into an area or chamber already containing a particular type of moist which look like mist or cloud, which awaits to receive contact and form bigger droplet. This physical contact is usually referred to as coagulation. In other way of describing this probably is the moist air, which contains air impurities, are being lured by force to enter a space where cloud of mist are already suspended and collide and contact and forms a mixture of wet droplets of a higher density. Being denser, the newly formed droplets shall obey the law of gravity and sink to the bottom of the chamber as scrubber liquid. This liquid, however, is being reused as scrubbing agent over and over again until it gets saturated. Then this contaminated and dense scrubber liquid must be released and replaced by fresh scrubbing agent. Air which has been stripped off are now relatively cleaner, thus being allowed to exhaust out via an outlet, chimney or stack, and released into the ambient air or atmosphere, which is supposed to comply with their related emission limits as per design or as regulated by their respective authority. Let's talk about the scrubbing agent. The liquid which forms the mist cloud inside the scrubber chamber or column. This liquid formed scrubbing agent is converted into fine particles to form those clouds of mist by means of the Venturi effect. Well, let's cut the crap of physics and make fluid dynamics fun. In the book, it is called atomization, meaning the liquid is transformed from liquid into mist. Lots of mist, very dense pack of mist, literally. How is this done? Watch this. You too have done the same, right? That is the basic Venturi effect for laymen like me. To make mist from the same technique, smaller nozzles are needed at the end of the pipe. Nozzle pipes. Greater flow pressure is needed, so we need those pumps. So high pressure flow in the pipes until the nozzle, then lower pressure in the chamber allows gas expansion, atomization. They get in contact, forms droplet of liquid which sink. So what are the principal factors which we regard as operational factors which facilitate the efficiency and effectiveness of the scrubber? As you have noticed, pump at certain pressure, chamber, range of pressure drop, recycle scrubber liquid, what is its threshold concentration before being released or discharged as contaminated water, which must be treated, isn't it? Now let's observe what auditors should look for, shall we? The first bullet, we as auditors needs to compare by the inches, literally, of what is written and what was drawn with what was built in front of you now. Location as in plant layout, scrubber types, whether identical to what is on paper. There are indeed several types. Any sign of modification? If there is, seek copy of notification which was sent to the authority. Now, second bullet, check operational pressure drop range. Wow. You need to look and read. Is it as per manual? Any record of clogging nozzles or leaking pipe joints or flow valves? Any replacements of parts of repair? Please check their maintenance books. Most important though, is the scrubber liquid or scrubbing agents? Yes, they were designed to be recycled. Yes, they can be topped up. Here you are. But they have a lifespan. Their lifespan shall depend on specific gravity or SG or concentration of solids or dissolved solids. Even if these scrubbing liquid are being replenished or topped up from time to time, it will eventually reaches its saturation limit, which, if the fluid is not removed, eventually the fluid piping valves and spray nozzles would clog. So at this point, the used scrubbing liquid is now a form of liquid or perhaps slurry. It is a waste. In this country, if it is stored in any form of container and to be disposed of as in its slurry form, it shall be regarded as scheduled waste. If this is the case, then you know what to look for: scheduled waste management. However, if this scrubbing agent is being blown down via the blow down pipes, then auditors needs to track down where is it flowing to. Please ask for comprehensive lab reports on chemical analysis done for this blow down scrubber slurry. Auditors needs to check if this liquid waste is falling under the effluent regulations. If it is subjected to this law, then it shall not be allowed to flow into any inland water systems, including groundwater or even the sewer system. It must be treated usually in a wastewater treatment plant until it is complying with the local or legal quality standards before being allowed to be released into any receiving drains or water body. However, if they are discharging into any municipal sewer, then you got to check for the approved documents, okay? So with all these findings, please check their SOP. Is the instruction in their SOP or operational manual parallel to the legal requirement? Personally, I have encountered several of these kinds of inconsistency. Their operational manual is correct in technical terms, but contradict the law. No surprise, it happened. So your legal knowledge, it is still a priority. You may find in their manual several parameters of concern for the effectiveness of their scrubber. Common parameters are pH, specific gravity, and the top-up and blow-down rates of the scrubbing liquid agent. It's good to look at this closely too, and this is a part of technical specification for their scrubber operation. Okay, then let's look further down to the third bullet, monitoring reports. This is primarily referring to what is being emitted out from any exhaust, ventilation outlet, or stack or chimney opening for the cleaner air from the scrubber system to be released into the atmosphere. What to look for? Environmental parameters and results. Please determine if the parameters are applicable for the technical requirement and the law, approvals or permits. Are the data showing compliance to both standards? It would help you most if this was already done during your documentation audit. In my case, I have it jotted down in my pocket notebook. Let's go to the fourth bullet then. Personal competency or DOE approved competent person. I believe this is purely administrative and legal in scope, and you may do an interview just to verify his technical know-how for the scrubber in question. Good luck. So let's go to the next slide. Here's another version of the Venturi Scrubber. This picture was captured in a hard disk drive manufacturer here in Malaysia. The air pollutants are in the form of acid mist or acidic gas stream. It originated from several metal treatment processes using concentrated acid bath. The volatile acid fumes were extracted and brought into the scrubber, a horizontal Venturi scrubber, right? As you can see, scrubbing agent being sodium hydroxide diluted to certain molarity, and the scrubbing technique involves scrubbing liquid in bath, then pumped to the top and sprayed down as mist. The acidic gas stream which flows in collided with the scrubbing agent and forms liquid which is collected at the lower part of the scrubber itself. Yes, the contaminated scrubber liquid are being pumped from this basin and reused or recycled as explained earlier. So it is identical in terms of operating principles, but in a different plane. I was told by the operations personnel that this layout or configuration was due to the presence of microscopic metal dust in the acid fumes extracted from its process origin. In reality, scrubbers are usually customized to the types, nature, and characteristics of air pollutants that constitutes the incoming wet or gas streams. So if you are keen to know of other variety of this scrubber system, you may look out for it, such as condensation scrubber, impingement plate scrubber, mechanically aided scrubbers, orifice scrubbers, and there are many others within that types that I mentioned. It can be interesting for some of you. So, alright then, I hope this video adds on to your existing revision notes. This is the best that I could afford to for a video. Unlike face-to-face, we had much more fun, especially when I have access to the huge whiteboard. Well, until we meet in the next video, inshallah, I wish everyone in good health and zest in auditing. To my brothers and sisters, I wish you all Assalamu alaikum wa rahmatullahi wa barakatuh.